Okay, Excellencies, distinguished participants, colleagues, while colleagues are loading presentation, let me start with the introduction of what I was going to talk to you today. To begin with, I'm really very pleased to have a chance, an opportunity to talk to you today. This distinguished gathering is very, very important in the current context of what's going on. And as I told in the corridors before getting here to the professor who is a chair of the advisory committee of INFLORES, everything is related to everything else. Everything is connected. And now what I would really like to see is everyone is connected to everyone else. So I would begin thanking organizers very warmly to get us a chance to talk to you. And of course, INFLORES and Dr. Ardakanyan, but also Technical University of Dresden and Leipzig Institute. And I'm really very pleased to be in this beautiful city of Dresden. I've been there a long time ago in my childhood, and my memories are popping up in today's. I come from WMO, World Meteorological Organization. For WMO, the Nexus approach is something very apparent, very evident, and very organic. It's like in DNA of every meteorologist in the world. Everything is related to everything else. But despite the scientists were talking about their interrelations, especially in the climate system, this was not really coming into the way economies operate, into the way cities are built, and to the way how the different parts of the society are interacting with each other. And the year of 2015, which I call, not only me, many people call it the decisive year of our history, it's a really huge opportunity for us all to make these connections penetrate into the life and the thinking of everybody, despite of which sector we work with. 2015, and Dr. Mare mentioned this a few minutes ago, is a really special year. It's just 2 weeks ago, actually less, there was a disaster risk conference in Sendai, World Disaster Risk Conference in Japan. This conference is happening only every 10 years, and that time it was talking mainly about resilience. That is a major shift in the thinking about disaster approach of prevention and resilience since what has been discussed 10 years ago. How this is connected to climate, I will try to explain in a few minutes. Then in September, indeed, and Dr. Ardakanyan mentioned, there will be the General Assembly debate and decision on the Sustainable Development Goals. We all know that the Millennium Development Goals established by Millennium Summit are coming to the end in 2015, and now governments are thinking what should be the Sustainable Development future. If you have ever seen the synthesis report of Secretary General, the document which is going to the General Assembly, it will display you 17 goals which members would like to see, the future Sustainable Development Goals. You will see water, you will see health, you will see food security, you will see education, gender, oceans, and many other things. You will also see climate. You would not see disaster risk because it's considered to be the cross-cutting. I don't really think that it's a good idea to make climate change a goal, but because it also affects any other goal. So governments understand that everything is related to everything else, and they do struggle how to make this transformation in the way policies are set and the way economies work. So that's why your conference is one of few which is right now very relevant to what's happening. We need to help governments to make it happen and to make it work. And they are looking to us scientists for scientific advice. So I think my two key messages today would be, whatever happens, and a lot of transformation is already going on, everything needs to be based on science. It needs to be advised by science and needs to act on the basis of scientific knowledge. And the second key message is that whatever happens in whichever part of the world, we, at least multilateral system, we need to make sure that no one left behind. So we need to help those who are more behind in their understanding how to make it happen. So I have a long presentation, but I know I have only 20 minutes. I will try to be concise. So we'll first talk about, We'll first talk about status of climate system. Whatever I'm showing here, I'm going to base on the WMO authoritative information. WMO issues annual climate statements, which is consensus information on the current situation in the climate system. WMO also issues annual statements on the greenhouse gas concentration, which everyone is aware of, and it's trustful information because it's good objective measurements. And of course, I will also base large part of presentation on the conclusions of the IPCC, Intergovernmental Panel on Climate Change, which is, I would say, baby of WMO and UNEP, established by us collectively. And they have just completed in 2014 the 5th assessment report, which is very rich information of climate science, climate state, physical state, impacts and vulnerability, and mitigation actions. So the climate system is a very complex system, and one shouldn't simplify it, because when we simplify our conclusions, for many people who are not working in our area, who are not scientists, they don't trust it very much because they understand the complexity, they see uncertainty, they see that there are many things we don't know. So we have to communicate this too, because humans are very used to actually base their decisions in uncertainties, which is the case with the climate system. Everything is interconnected in climate system. Water cycle, carbon cycle, ocean circulation, atmospheric circulation. A slightest change in any part of the system triggers a response everywhere else. And how this response behaves, it's a challenge for climate modelers, for those who are simulating the climate, to see how this reaction would be. So those of you who know IPCC 5th assessment report, and those who don't, I really encourage you to read at least summary for policymakers. It operates on the basis of 4 scenarios of different parameters. What will happen at the end of century if? And the scenarios are 4: most radical reduction and business as usual. So you will see at the end that we would probably want to be somewhere in between, and the decision is pretty close in the Conference of Parties in Paris, COP21, UNFCCC. So all the climate system is interacting amongst its elements, but everything is based on the energy balance. The radiation coming from the sun should normally be the same radiation going out. However, you all know that the greenhouse effect, which is very important effect for the human beings and for the biolife, because it preserves the warm temperature on the planet, which in the prehistorical past was 14 degrees Celsius surface temperature, now is altering. So what happens with the greenhouse gases, and this is the most recent report again of WMO, that the 2014 was a year where we hit 400, what we call ppms, parts per million. Those of you who know the paleoclimate would recall that during the cold phases in geological history, average global and decadal average global temperature was lowering by about 5 degrees, and CO2 was about 180 ppms. In the warm phase of geological history, the concentration of CO2 was reaching about 300 ppms. And as long as we could look back, and the objective data are derivatives coming from the ice cores, we could look back at 800,000 years. This pattern remained 180 to 300 ppms. However, last century, which is only 100 years, we have managed to accumulate extra 100 ppms in the atmosphere. So this change is clearly very fast. It's 100 times faster than in any time in geological past. And this is happening during the warm phase. So the greenhouse gas remains in the atmosphere also for hundreds of thousands of years. It takes a long time for phasing out. There are geological processes which are responsible for that. And in the last statement of WMO, we also observe that though the emissions of CO2 are starting to decline its speed of raising, still raising but not so fast since recent. However, the concentration of CO2 remains same. It doesn't show response yet. So IPCC says human influence on the climate system is clear. And you also see on the lower graph the contribution of fossil fuels, cement and flaring, versus forestry and other land use. How it translates to the surface temperature, again, from WMO statement, 2014 was the warmest year in the record, and last 14 years out of 15 were the warmest years ever occurred in 21st century. So 2014 is actually 0.57 degrees warmer than the average 14. Doesn't seem to be a big figure, but in the scale of the planet, this triggers a lot of change. The graph would also show you some colorful bars. Those which are red, they correspond to El Niño years, which is warming. Those who are blue, those correspond to La Niña years, which is cooler. So you see the natural variability there. The curve is not very flat, it's very variable. And usually the warmest years are red in the year of El Niño. And 2014, we actually expected that would be also El Niño year. However, until now, our statements are saying that it's not yet happening, it's still neutral year, but there is still some likelihood that it could El Niño can develop later this year. Maybe it would be moderate, maybe it would remain neutral. However, the 2014 is already the warmest year. It's better to actually take a look on the decadal averages rather than individual years. And according to WMO, we are usually looking at 3 decadal cycles. However, even decadal information shows very clearly that every next decade is warmer than any decade in the past. So surface air is warming, but I would also like to make a point here that we also know that the upper atmosphere is cooling. The stratosphere is becoming cooler, which rules out the effect of sun. The ocean temperature is warming too, and you know that more than 90% of energy that accumulates in the climate system ends up in the ocean. The ocean temperature again hits records, and we have quite long-term records from 1955 for the ocean surface, but also 700-meter temperature. But since recently, from 2005, we deployed the buoys, which are now measuring the ocean heat content and anomalies at the level of 2,000 meters, 2 kilometers. So both are raising up, and this is, again, recorded in the statement and used by IPCC. The more interesting story with the sea level rise, which actually is one of the indicators which no one who is not from scientific world can argue. The mean sea level rise, or the map which we see on the screen, it's a sea level trend from 1993 to 2013, continuing to rise, and due to mainly 2 reasons: melting of ice and thermal expansion. The warmer the ocean, the more volume water takes. However, what's interesting to know is that, and this is this question which very often is being asked to us, why you think it's human effects? We explained it the way by saying that in the latter part of Holocene, which was long after last ice age, the fluctuation of the sea level was not more than 0.2 millimeters a year. During the 20th century, IPCC states that the sea level was rising at the average rate 1.8 millimeter a year. Last 20 years, it's already 3.3 millimeters a year. And the projection for the future, near future, would be 10 millimeters per year. And the 10 millimeters per year, that's about the rate when the ocean was rising, when the ice was melting at the end of the ice age. But we are now in the warm phase. Another interesting thing to take out of this picture is that the sea level rise is not even across the planet. There are places which are red, it doesn't work. The places around Indonesia and Philippines, you can see the large red spot. In their coastal areas, the sea level is already about 10 millimeters per year. And this is very important when we talk about effects of tropical cyclones, which is main business of WMO, the disaster risk reduction and early warnings. In these parts of the world, the storm surges are becoming much higher than ever before due to sea level rise. So this needs to be factored. So in the annual statements, we usually display the most notable anomalies. I won't talk much about this. I looked at the program. I know that you have across these 3 days many case studies on different issues, but you can see that every year in the statement you would see different anomalies in terms of droughts, heat waves, coal spills, and floods. The more we disrupt our climate, the more we risk severe, pervasive, and irreversible impacts, IPCC said. And in fact, yes, I don't have a graph here in the presentation, but there is quite a clear correlation between the rise of the temperature and the frequency and intensity of different disasters. And we all know that majority of them are hydrometeorological nature. And of course, WMO is extremely concerned in getting warnings in the good time, more accurate, multi-hazard early warning systems, and this is core business of WMO. One slide, I can't top on this because I don't have time, but if you would go to WMO website, you would find very quickly on the first page the weather reports from the future. We started this before Lima conference, and actually even before Climate Summit in September, and this became a very popular thing, which is very good communication tool. In every country in the world, there are weather presenters which are showing up on the television on the prime time, and every person knows them, children and elders. And of course, they work with the National Met Services, and we asked them to create a story about the weather forecast in 2050. So by now, we have about 20 plus countries who have done that, and they usually bear the very powerful messages. So imagine this weather presenter showing up on the screen and starts talking about droughts, about heat waves, and he shows or she shows maps of devastating floods, and the people are confused what's going on, but then they realize this is about 2050. So I'm moving to the next part. So the IPCC have analyzed physical science, and the second part of the report talks about impacts and vulnerability. So this slide presents water resources in the +2 degrees world, and you can see clearly that some parts, I would say large Mediterranean region, would have been water resource scarce, but there are other parts of the world, mainly in the northern hemisphere, in the high latitudes, where the moisture would be much higher than now. That's all available in the IPCC reports. Arctic summer sea ice, we continue to record year after year the record minimum of extent of the ice. But interesting fact is that in Antarctic, actually the ice volume is not decreasing, but we can judge on the changing ocean circulation in the Southern Ocean, but also atmospheric circulation. It looks like the precipitation in Antarctic are creating a new and contemporary ice mass in quite substantive volumes. But this is also effects of the changing climate system. The glaciers are declining very rapidly. IPCC recorded that last decade 600 glaciers disappeared, and they will continue to disappear. There is also information on the water equivalent in the glaciers. It's extremely important for those countries whose water management is based on the glaciers. water, not precipitation per se. So this needs to be monitored, and in order to have better information on the cryosphere, we started in WMO the new network, which is Global Cryosphere Watch, to be sure that we have good objective information on all glaciers and all frozen water on the planet. Of course, the end of 20th century was remarkable by a number of extreme floods, and this shows the model agreement that how many countries or how many places would be affected by the I would say flood of the century. So the floods which were most remarkable during the 20th century, would such floods increase in the future or not? So again, you can see that it would likely be less frequent in Europe, but it will be much more frequent in the big parts of South America and Africa, and also in Asia. Exposure to floods is also the parameter which can be found and justified in IPCC report. This shows number of people in millions which would be affected by exposed to floods exposure. The black curve shows the historical record, historical mean, and the colorful graphs show the scenarios, show with how many people could be exposed, depending on the scenario. So as I told you in the beginning, there are 4 scenarios. So the dark blue line represents the most radical emission cut scenario, RCP 2.6, and the red line represents business as usual, RCP 8.5. So you can see that the choices we have and the choices governments have are here, but how to act, we need to help. And we need to provide them with the policies, advice, and with the science. Ecosystems also shift, and here there would be indication of changes in terrestrial and freshwater ecosystems in the second half of the 21st century, especially under high warming scenarios. So here it's scenario of RCP 6 and 8.5, high warming, high confidence. So direct impacts on such as land use and change of land use, pollution, water resources development will continue. And that is how that would be spread at the end of the century. Fire hazards, again, the pattern's changing. Even now we see the places where the fires, forest fires and bushes fires are taking more and more taken more and more frequent, but they were not happening in the past in these places. So again, it's model agreement. You would see that the fire hazard would increase in most of Eurasia and North America, but probably decrease in the southern hemisphere, except for southern part of Australia. Coastal flooding. I talked about sea level rise in the beginning. I think it's also important for the nexus, which you will discuss here, because of urbanization and population, which is occupying most coastal areas, and the exposure of those populations would be what you can see on the screen. It's a projection for the last 20 years of current century. Estimated increase in height and flood protection structures that you need to build to protect the people. So the red dots clearly indicate that here the exposure is very high. So if you put a lot of people in these coastal areas and don't create shelters for them or protective systems, then they would be very vulnerable. Ocean acidification more matters perhaps for other type of nexus, which I don't know where to go to talk. However, this is something which needs to be really looked at very, very deeply into. Since last year, we started in WMO adding to our regular product on greenhouse gas concentration in the atmosphere. We also started, in collaboration with UNESCO, adding ocean acidification component. So here you would see the kinds of life spread it all over the planet, which are actually vulnerable to high to acid water, and it's extremely important for, of course, for fishery mainly, but also for other human activities and economic activities. We also know that about 30% of CO2 which we emit is absorbed by the ocean. However, scientists are not quite sure how much more ocean can absorb. So we can only base, there is no understanding of physical processes right now, how much more can be contained in the ocean. But acidification is certainly probably not very good sign for a lot of biolife in the ocean, and of course people who depend on it. Marine fisheries I will skip because it follows the previous statement. Urbanization, I would encourage, you have a whole day of urbanization, and I hope you will be talking about also contributing to the Habitat 3 conference in 2016. So you know that today we have 37 megacities, and the projection for the mid-century will be to double number of megacities, and most of this urbanization is happening in the developing countries. So there is a lot we need to do here, and our sister agency, UN Habitat, is aggressively, in a good sense of it, is now developing the concept of climate-smart cities, and that is here you can really help, because high number of people in the same place creates a lot of exposure. So it's not for me to tell you how important the Nexus approach is, and you seem to have all the drivers right. So just recognition that we appreciate what you're doing very much, and if we can contribute further from the viewpoint of WMO, we would be very pleased to do so. I also had a couple of slides to show some country projects, but again, I look at your program. Let me not talk about this too much, and I don't have time. But the main message is here that even you scientists sitting in this room, I'm absolutely sure that every one of you understands the IPCC report, but even for us, it is still a global picture with some attempts to downscale it to the regional scale. Now we need to deal with the local level, with the villages, with the cities, with the households. So that's a translation of what global science tells to the life of local people. That's something we have to help. And I would hope that most of your presentations would be about this practical help, how we can use the science in the best possible way to take right decisions. So in WMO, we understood that living within meteorological community is not an option anymore. We have to go much broader and talk to transport, talk to health sector, talk to economists, energy, and all sorts of users, because one thing we know on the climate system, and the other thing, what type of information in terms of projection, forecast, advice we want to present. So we are now started going from the physical forecast on the precipitation, wind, or temperature, to what we call impact-based forecasts. What if? So what would happen if this would be the weather? So this is Global Framework for Climate Services. It's broader than WMO, though we are leading on that. So the last slide. I know, I see the last slide. So that is a friendly presentation attempted by, I think, Cambridge University, yes, to show how much we have left in terms of CO2 emission. So the message is very simple. We have a limit of 800 gigatons of carbon if we want to stay below 2 degrees. Some wants to stay 1.5 degrees, but at least below 2 degrees, and that is a decision of the UNFCCC. So we have already used 530 gigatons, and we have only left 270 gigatons of carbon to burn if we want to stay until below 2 degrees. With the current rate, we are burning 10 gigatons per year. So we have 27 years more, and that's it, full stop. So the passionate message of UNFCCC to everybody, we want to be climate neutral by the end of the century, and we are asking everyone to help this to happen. So I think that I have communicated main messages I wanted to say. A lot of transformation is happening. There is now many incentives for many energy sector and water sector. This all should be based on science. And as much as we can, we have to continue giving this advice, better and better advice in terms of products, guidance to those sectors from all the corners. We would be happy to join any discussion like this one, and we would be happy to see the Nexus approach spreading over the rest of the sectors. Thank you very much.